All right, now we're going to go through example 2. So it says plot the graph of the following equation written in slope-intercept form. So we have the equation y equals negative 3/4 x plus 5. Now I know the negative is written like right in front of the fraction, and the negative can be applied to the numerator or the denominator of this fraction. Does not matter. It can only be applied to one location, either the top or the bottom, not both. Okay? So let's write down all the information we have. So when it's in this form, one piece of information we have is slope. Slope is the number being multiplied by x. And so I'm going to write the negative sign in the numerator, but it really doesn't matter. So my slope is negative 3/4. Remember that negative 3 is referring to our rise, our vertical movement, and the 4 is referencing our run or our horizontal movement. We're also given our y-intercept, or where this graph crosses the y-axis, and that's a positive 5. In order to use this information to graph, remember we first have to graph the y-intercept. So I'm going to draw my grid here. All right, and then I'm going to begin plotting my points. So I cross the y-axis at 5, so I plot a point there. Then I'm going to count down 3 units and to the right or forward 4 units to represent my rise over run. So I go down 1, 2, 3 units, and then I run forward 4 units. 1, 2, 3, 4, and then get my next point. From there, I can connect, and there's my graph. Notice in the textbook they did it a little different. They apply the run first and then the rise. I don't love that because I like to go in order of numerator then denominator, but it clearly does not make a difference. Okay, so whichever one makes the most sense to you, go forward with that method. All right, let's go through example 3. We want to plot the graph of the line represented by the following equation: 4x minus 6y equals negative 24. Now this is in standard form, so we can use the shortcuts that we discussed at the beginning when we defined standard form to identify our x and our y-intercept. So the shortcut to identify our x-intercept is to take c divided by a. C is negative 24 and a is 4. So we get negative 6, meaning we cross the x-axis at negative 6. My y-intercept is c over b. Well, c is negative 24 and b is negative 6, giving me a positive 4, because a negative divided by a negative is positive. From here, I can draw my grid. And I can plot my points: negative 6 on the x-axis, 4 on the y-axis, and connect them to get the picture of my graph. All right, let's keep going and take a look at example 4. I think now would be a good time, if you're feeling really confident with this material, maybe pausing the video at this point and then pressing play when you're ready to see the answer for example 4 and see if it matches me. So example 4, plot the graph of the following equation written in slope-intercept form. We have y equals 2/5 x minus 3. Right, here my slope is 2/5. So 2 is representing my rise, and the positive 5 is representing the run. My y-intercept, or where we cross the y-axis, is negative 3. Biggest thing with these problems is making sure that you are staying consistent with your signs. So 1, 2, 3, 4, 5. 2, 3, 4, 5. Just drawing my grid. All right, plotting my points now. So again, we have to start with our y-intercept at negative 3. Then we apply the slope. So I'm going to rise 2 units, 1, 2, and then I'm going to run forward 5. 1, 2, 3, 4, 5. And that'll give me my new point. And then I connect them to get my picture. All right, last problem, example 5. So example 5 says to rewrite the equation in standard form, that's written in standard form in slope-intercept form, then state the slope and the y-intercept. So this should be a little bit of a review of the last concept, but it's 4x minus 5y equals 60. Slope-intercept form means it's been solved for y. So we want to focus our attention on getting the y term all by itself. So I have this positive 4x that I'm going to need to subtract over to give me negative 5y equals negative 4x plus 60. Again, I cannot combine the 4x and the 60 because they're not like terms. One of them has an x variable attached to it, the other does not. So I have to just write them next to one another. I can't actually add those or subtract those numbers together and have it be one thing. It has to be 2 separate pieces. Now the negative 5 is being multiplied by the y, so I need to divide everything by negative 5. What that looks like is when I do negative 4x over negative 5, when I divide those two pieces together, that's like doing negative 4 over negative 5, and then the x just being written behind it. So it's just dividing the numbers. Okay, then I have the 60 divided by negative 5 as well, like this. Doing a little bit of simplifying, whenever we have a negative divided by a negative, that's really a positive. So I really have a positive 4 over 5x. 60 over negative 5 is negative 12. So I can really turn that into a minus 12. You could have also said plus a negative 12, and that would have been just as right. Okay, so that's the end of Concept 7. At this point, you can move on to the review problems, and then when you're feeling good with that, you can move on to the Concept 7 homework assignment.